Hi, and welcome to the new episode of CQURE Hacks. Today I'm going to demonstrate how simple misconfiguration in Azure storage services can lead to data exposure and even leaked cloud credentials. So let's begin. As we can see, the website mentions that the images are loaded from the Azure Blob storage. So let's inspect the source code and see if we can find the actual storage URL. It looks like the app.js file exposes the full storage account URL, including the container name. That's already valuable information. So let's check whether we can access it directly. By adding the REST type container and complice parameters to the URL, we can attempt to list the contents of the container. As you can see, we are able to list the contents of the Blob container. This confirms that anonymous listing is enabled. We can also directly access and download the raccoon images displayed on the website. So, what would be the next logical step here? If one container is publicly accessible, it's very common that others within the same storage account might be misconfigured as well. That's where container name enumeration comes into play. We've already prepared a simple script and a word list containing common Blob container names. So let's run the brute force and see what we find. As you can see, we've identified 3 containers: pictures, which we already knew about, dev, and backup. Now things are getting interesting. Let's now try to list the contents of these newly discovered containers and see whether they expose anything sensitive. Let's start with the dev container. Here we have the internal node addressed to Mike. We noticed that a service principal credential file was uploaded to the backup container last week. Please do not store any credentials in the Blob storage going forward. This is exactly the kind of sentence that immediately raises a red flag during a penetration test. It tells us 3 things. Credentials were stored in Blob storage. They were deleted. Someone thought that deleting them was enough. Let's move on to the backup container. We have some interesting files here. Let's take a look. The manifest mentions a file called Azure-spjson, but it's marked as deleted. So far, the backup container looks clean. We don't see any credential files in the current listing. But Azure Blob Storage supports object versioning. That means even if a file was deleted, previous versions may still exist in the background. To check that, we need to explicitly ask Azure to include historical versions. Here we are doing 2 important things. First, we are adding include equals versions, which tells Azure to show us historical versions of blobs. Second, the XMS version header, which simply tells Azure which storage API version to use. And this particular version supports working with Blob versions. As you can see, we have a previous version of azure-sp-creds.json. Now that we have the version ID, we can request that exact historical copy of the file. In this request, we are not downloading the current version of the file. We are explicitly asking Azure for a specific historical version using the version ID parameter. And just like that, we have recovered a file that was supposed to be deleted. Well, let's open the file. Inside, we can see client ID, client secret, tenant ID. Well, these 3 values are enough to authenticate as a service principal in Azure. A service principal is basically a non-human identity in Azure. It's what applications and automation use to authenticate to the cloud. So let's use these credentials. We are able to successfully authenticate in Azure. Now let's check whether this identity has access to any resources. As you can see, the service principal has access to a key vault called Raccoon Secrets. Let's see whether this identity has access to the secrets stored inside that key vault. This command attempts to list all secrets stored in the vault. The request was successful. Let's retrieve the secrets and see what's inside. And just like that, we have recovered an administrative password and a DB password stored securely in Key Vault. This is where the real impact becomes clear. We started with publicly accessible dev and backup containers. We discovered that Blob versioning was enabled. We discovered deleted service principal credentials. And from there, we gained access to secrets stored in Key Vault. The issue was the combination of public container access and enabled versioning. When secrets are uploaded, even temporarily, and versioning is active, deleting the file is simply not enough. So guys, hopefully you enjoyed that hack. Please subscribe to our channel and see you in the next one. Stay secure.